Ever stared at the night sky and wondered if reality is just a cosmic prank? Welcome to quantum mechanics, the strangest, most powerful theory in science. It's the invisible rule book that governs how atoms, light, and everything else in the universe behave. It built your smartphone, powers lasers, and explains why the sun shines. Yet it also insists that the universe doesn't quite make sense in the way we expect. Let's dive in. No math degree required. The world is not what it seems. In everyday life, things have definite positions and speeds. A ball is here, not there. But in the quantum world, particles like electrons and photons don't follow that rule. They exist in a superposition, a blurry state of being in many places or conditions at once until we look. Think of Schrödinger's cat, a poor feline that's both alive and dead until someone opens the box. That's not just a joke, it's the real logic of quantum physics. Observation doesn't just reveal reality, it creates it. The dice game of the universe Einstein once said God does not play dice with the universe. Quantum mechanics respectfully disagrees. At the quantum level, outcomes are fundamentally random. You can calculate probabilities, but never certainty. Drop a photon through a slit, and it might go left or right, but you'll never know which until you catch it. Reality, it seems, is built on chance. The double slit experiment, proof of the impossible fire. A beam of light through two narrow slits, and you expect two bright lines on the screen, like bullets through two holes. But that's not what happens. Instead, you get an interference pattern, a ripple-like display showing light behaving as a wave. Now shoot photons one by one. They still form the same pattern, as if each photon interferes with itself. It's as though a single particle travels through both slits at once. When you observe which slit it goes through, the pattern disappears. Observation literally changes reality. Entanglement, spooky action at a distance. Imagine two particles created together. Even if you separate them by billions of kilometers, measuring one instantly determines the state of the other. This is quantum entanglement, a phenomenon so bizarre that Einstein called it spooky action at a distance. Yet it's been proven again and again, and it's the backbone of future technologies like quantum computing and quantum communication, where information can be shared more securely than ever before. Quantum to the rescue, technology of tomorrow. Quantum weirdness isn't just philosophical, it's practical. Here's where it already powers our world. Semiconductors. The brains of your computer rely on quantum tunneling. Lasers, built from quantum energy transitions. Quantum computers use superposition and entanglement to solve problems impossible for classical machines. Quantum networks promise unhackable communication through entanglement. The future is quantum, and it's already here. So what is reality, really? That's the ultimate question. Is the universe fundamentally random? Does observation create existence? Or is there some deeper layer of reality we haven't yet cracked? Physicists like Niels Bohr and Richard Feynman learned to accept the strangeness. Feynman famously said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." Maybe reality isn't supposed to make sense. Maybe weirdness is the code of the universe. Quantum mechanics shows us a universe that's playful, unpredictable, and profoundly mysterious. It forces us to rethink what real means, and reminds us that beneath every solid thing lies a cloud of probabilities and potential. So the next time you look up at the night sky, remember, the universe isn't made of things, it's made of possibilities.